All right, here we are with day 7 on Advent of Code. No space left on device. Same old wonky device we had in day 6, but this time there's not enough space to run some of the code we need to run. So we get an input that's a bunch of commands and directories and files. I'll let you read through the input yourself. What this thing is asking for is it wants us to find all directories with a total size at most, what's this, 100,000? And what is the sum of the total sizes of all those directories? So my approach to this is to try to get as modular as possible. We're going to build the file system first, and then we're going to build functions that let us find the size of directories and files. And also we're going to build a function that finds all the directories with sizes that are at most 100,000. So let's hop into it. Building the directory is no easy task, or the file system I should say, so we'll tackle that first. We're going to import this function readFileSync from the FS library. And then I'm going to define this interface. Let me get rid of this. Alright, I'm going to find this interface called FSItem. And I want a FSItem, that stands for file system item, to have a type that's a string with the name file or directory. It's going to have a name. It's going to have an optional size that's a number. In reality, these are all going to have size at the end of the day, but a file has a size right there with it, and a directory size we'll find later. And then I want to track its parent, so the parent is the directory that contains it. So the parent will be either null or a file system item. And the children are going to be an array of FS items, or null. If it's the end of the tree, then it'll have no children. And essentially what we're doing is we're building the file system is we are building a tree. So I'm going to declare a variable fs that is an array of file system items. And I'm going to add the root directory, which is always present. And after that, I'm going to delete the first line of our input. So first thing I'm going to do is I'm going to push to fs an object of this type, which will know that it's a type of fs item. So type is directory, name is /, it has no children at the moment, and the parent is null. Let's see, let me open up the input for this one. I mean, you saw it on the site, but the input we have here is quite a bit longer. Back to our code, let's keep going. Root is going to be fs of 0, so we're just setting a variable called root and getting the first item within a file system variable here. Now we want to open our input file and read its contents. Oh, when I say note I deleted the first line of input.txt, what I meant by that was, you'll see I start with ls. It doesn't have, I think the problem here, well, if I get my input for you, then you see it's got cd/ as the first. But I just got rid of that because I just add it manually. All right, continuing on here. So we've got our file. Now we're going to split the data into rows, and all I have to do for that is file.split on the new line character. And now I'm going to declare this function called buildFS, or build file system, and that's going to take a directory and an input line number. And what I want to check is if there's no input line number, then I'm going to return, so essentially we've reached the end of file. Otherwise, I'm going to declare these variables within an array first, second, and third, and the rows of input line number dot split. So we're splitting the line. I think, yeah, looking through this, the most you'll have are 3. You have the $ls, $CD, FTS, so that would be 3 items. Most of them are going to have 2, in which case the third is null. But we're just, essentially what we're doing is we're parsing the string into an array of variables called first, second, and third. And so first thing we're going to do is we're going to call parseInt on first. And if that is not a number, then we know that the type is a file. So all of our files have this number in front of them. So we're looking for something that starts with a number. And the other thing we know about files are that they have no children, right? Because they're not directories. So we're going to push to our current directory.children this object that's going to be an fs item. We'll give it a type file. We'll get the size from the variable first. We'll get the name from the variable second. Children are null, and the parent is the current directory. And then recursively, we're going to call buildFS of dir, but we're going to add one to input line number. So we're going to go to the next command in our input.txt. So if it's not a file, then we pretty much know it's a dir. I say dir or directory, but it could be a command or something else too. So now we want to treat the case when we know it's a directory. And so for directory, we're going to push, similar to how we did to file, just an object of type directory, name second, empty array for children, and the parent is the current directory. And now we're going to call recursively build fs again, passing in the current directory and the next line number. So we're just taking care of the different cases of stuff that we'll see in input.text. Okay, so for the next condition, we're going to check if the first variable is a $, which means it's a command executed. Second is cd, so we're changing directory. And third is not equal to ... so we know that we're cding into a directory within the current directory. And what we're going to do is we're going to create a variable new directory, and we're going to say directory children.find, and we want to find a directory that has the name of third, because we know that we're cding into, so here $directory into a directory that exists because we already listed it, right? And then we're going to recursively call build fs again, and this time we're going to pass in new directory and input line number +1. Our next case is that we're actually going to go up a directory, so third equals this ... string, and we'll get the new directory as the parent of the current directory, and we will build fs recursively with that new directory and input line number +1. And then lastly, any other case, we just want to pass the current directory and input line number +1. Maybe we're listing or something like that. This is kind of a catch-all case. And then we're going to call build fs on root, and that will recursively go through and build our file system for us. All right, now we want to start working on solving that. Now that we have our directory, we want to work on solving this problem. And to solve this problem, we're going to write this function called getDirectories with size less than, which will take some sort of size. The problem asks for 100,000, right? So let's go ahead and define that now. So use the directory size to get a map of directories with size less than 100,000. We're declaring the function here. It's got a parameter of size, which is a number, and it's going to return an array of fs items because we're getting multiple directories. So we'll declare that dirs variable, and it's an array of fs items, and right now it's an empty array. And then when we're done with the function, we're going to want to return that. But first we're going to need to traverse the file system tree looking for those directories with the file size less than what we specified. So I'll call traverse of root, and I'm going to define that traverse function right above. Takes in a directory. If the directory.type is directory, then we're going to declare a variable directory size, get directory size. And now we have to recursively go into that directory and get all the sizes of everything in there. So let's go ahead and define a function that does that for us. Get a size of a single directory. We're declaring that function here. It takes in a directory which we've passed down here and spits out a number. So we'll let size equal 0. If we find a file, then we know the file has a size to it, right? So we'll return directory.size. Otherwise, we're going to go into the directory's children, and we're going to recursively call get directory size of that and add it to this size variable. And then we'll return size. So now we know we have the size of everything within that directory, and we can come back down here, and if the directory size is less than the size in our parameter, then we will set directory.size equal to dir size. And we'll push that directory onto our tracker, our global tracker up here. It's not global, it's scoped within this function. And then for each child of the directory children, we're going to traverse. So we'll recursively call this function here to do that. Okay, so now we know that we have an array of fs items that contains directories all with size less than 100,000. Now we want to sum the sizes of all those directories. So to do that, we're going to call the reduce method on that variable that we just defined. And the reduce method takes 2 arguments. The first argument is a function, callback function that has an accumulator and directory. And for that, we're going to add the directory size to the accumulator. And then the accumulator needs an initial value, and that's going to be 0. And now if we console log sum of directories with size less than 100,000, I'll save, and I'll go ahead and run this. And we get 1,642,503. So let's double check. That was part 2. 1,642,503. Okay, let's move on to part 2 now. Part 2, you're ready to choose a directory to delete. And this one here, we need to find the smallest directory that, if deleted, would free up enough space on the file system to run the update. And it gives us some constant sizes that we need to know about the file system itself. So I'll go ahead, and for part 2, I'll define those constants. So our total disk space is, what is this, 70 million? Yep. And the unused space needed to run whatever it is we want to run on our wonky device is 30 million. So we know that we can define a variable called unused space, and we'll say disk space minus get directory size of root. So we want to know the size of our whole file system as is, because right now it's too large, right? And so the delta that we need to look for is that's unused space needed minus the amount of unused space. And so now we're going to define a generic function to get directories with size greater than a certain size that we specify. That might be a little confusing, their size greater than size, but eventually, we're going to pass delta in there to get what we want. So directories with size greater than, this is a function that takes in a size and spits out an array of file system items. Very similar to what we did with our function before, we'll define a variable called directories, set it to an empty array, and then we're going to want to traverse the whole file system. We'll return directories at the end. I think I just forgot to put that down there, but I'll get to that in a second. So we're going to declare that traverse function. It's going to take in a directory. If it's a directory type, then we want to call our get directory size, which we've already written to get that size. And if it's greater than the size, then we'll add it. We'll add the size to the directory, and we'll push that directory to our directories variable up here. Then we're going to recursively call traverse for each child of the children of that directory. And at the end, we'll return the directories just like I said. Now we're going to go ahead and get all the directories with size greater than delta. And to do that, we're going to call this function directories greater than with an argument of that delta that we specified up here based on our constants. And now we want to find the directory within dirs greater than delta that has the smallest size. And to do that, we're going to use our reduce function again. We know it takes two parameters, a function as a callback and a initial size. This time we're going to start with a size of infinity. And if our directory size is less than the accumulator size, then we're going to return the directory. Otherwise, we return the accumulator. So this is just going to knock the accumulator down until we find our minimum size. Next, we'll just create a variable size of smallest directory with size greater than delta equals the directory that we got here dot size, and then we'll console log that. So let's go ahead and save and open up our terminal and rerun our code. And now we see we get, what is this, 6,999,588. So let's click on over to Chrome. Puzzle answer for part 2 is what we just said. And we've got 2 more stars. We're still going. We'll be at day 8, and I will see you there. Thank you so much for watching. If this helped, please like and subscribe. It helps me a lot, and I'll catch you in the next one. Bye. Yeah.